Part 5 of the GCSE Revision Guide. This covers algebra. Just a quick reminder, anything with the star is a calculator question. Let's just get started. Question 1a. We have triple brackets here to expand and simplify. I'm just going to use the arrows method, getting from one to the other. And I recommend just doing two brackets first. So I'm just going to do this and multiply out these. So x squared minus 7x plus 3x minus 21. I'm just going to simplify this. X squared minus 4x minus 21. Now I'm going to use this x squared minus 4x minus 21 to times by the third bracket. Okay, so doing the same thing again. X squared times x, that's x cubed. X squared times positive 2, that's plus 2x squared. I'm going to do the same with all the other terms. So that's minus 4x. So that should be squared. Minus 4x squared, then minus 8x, minus 21x, and then minus 42. And simplify the terms. X cubed minus 2x squared, that's minus 29x, minus 42. Just be careful with the negatives there. That's finished. Part B. We have a factorising question here. We have two terms, so this would be single brackets. Okay, so I'm going to pull out the 6. That's the biggest number I can pull out. I'm going to pull out the x. Then I'm going to pull out the y squared. Okay. Next thing is I'm going to fill in the brackets. What do I put in the first term? Well, I must get 6x squared y cubed. I've got y squared and 1x, so what I need is an extra x and an extra y. Next term, I need a 2 to get to 12. X are fine, and y is fine. That's finished. Question number 2. We have a solving question here. We have fractions either side of each other. What you want to do is just sort out the denominators. So I want to times this by 3 and times this by 4. This will remove the denominators. So this will be 4 times 2y plus 1 equals 3 times y minus 2. Times out the brackets, 8y plus 4 equals 3y minus 6. I'm going to move the 3y to the left hand side. So we want to get the y terms on one side. So I'm going to take away the 3y. Remember, you do the opposite to move from one side to the other. 5y plus 4 equals minus 6. I'm going to move the 4 by taking away the 4, both sides. 5y equals minus 10. And then lastly, divided by 5, both sides, and that'll be done. So y equals minus 5 divided by 2. Sorry, minus 10 divided by 5 is minus 2. That's finished. Question number 3. This topic is changing the subject of a formula, and we want it to get g on its own. Okay. This is one of the harder ones because it will involve factorising, which a lot of people forget that's what you can do when you're rearranging. So what I want to do is I want to get the g terms onto one side. So I'm going to take away the 2pg. I'm also going to take away the t, but I'll do that the next step actually. So I'm just going to do 3fg, take away 2pg, plus t equals minus 5f. Next step, take away the t, both sides. And this becomes minus 5f minus 2. Now that I have a g's onto one side, these are not like terms, so I can't combine them. But what I could do is I can factor out the subject. G times 3f minus 2p equals minus 5f minus t. As this g is times it by brackets, I can just divide through by the brackets, both sides. And that will get me my g on one side and everything else on the other side. So that'll be finished. Question number 4, we have a fraction, but we also have indices to deal with. What I want to do here is sort out the top before I do any division. 6 times 12 is 72. Y to the power of 7 times y to the power of 3 is y to the power of 10. Remember, using the indices rule. Here we have a raising powers rule. So if I take that as 2 to the power of 1, remember what you can do in this situation when you're dealing with brackets, you multiply the powers. So this would be 2 cubed, 3 times 1, then 3 times 2 is 6. Now that I've got this, I can now just simplify this a little bit more. The 2 cubed, for example, will be 8, and that'll be y to the power of 6. I haven't done anything to that yet. Now what we can do is I can just divide this. Now 72 divided by 8 is 9. Now this is saying y to the power of 10 divided by y to the power of 6. And remember what we do here is, as long as the bases are the same, we take away the powers. So this would be y to the power of 4. So it's 9y to the power of 4. Question number 5, we have a drawing, a graph situation, or sketching in this case as well. We have a table of values. Now what all you do here is you plug in these values into this equation, but do be careful with negatives. So what we do is we plug in x values to get our y value back, or our output. Do be very careful when you're dealing with negative numbers. Remember, negative times a negative, if we square it, will be positive. Although this is a cubic question because it's power of 3. Okay, so yes, you can use calculator, but I'm just not going to bother here. So this is going to be -8, -3 times -2 is +6, then +2. This becomes 0. So you just do the same with all the other values, and what you do is you get 0, 2, and lastly 4. Okay. Part B, on a grid, we're going to sketch this curve in this grid based on these coordinates. It's going to be a little bit awkward because it's quite small, so I'm just going to zoom in a little bit and then do the best we can to plot these points because we are using decimals, but it's going to be a little bit of estimating here. So this first one is -2, 0, -1, 4, -0.5, 3.4. So 3.4 will go about here. So I've done these three: 0, 2, 1, 0, 1.5, 0.9. That will go, so 1.50, but that will go there. And then lastly 2, 4. Okay, so this is a cubic equation and it's positive, so we should expect it to go something like this. So that's what will happen here for this curve. So I just need to join it with freehand. Let's go start here first, I think. Oh, I've already messed that up. Let's try that again. Okay, so notice when I'm going down here, what I'm going to do is I'm going to rebound off this x-axis because there's no more points and the cubic has to come back up. That'll do. And then lastly, final part. That'll do. So that's our cubic equation. So A and B are finished. Part C. Now this question causes a lot of confusion. By drawing a suitable straight line on the grid, use a graph to find an estimate for the solution of a different cubic equation. Okay, so our cubic equation here is 2x cubed minus 3x plus 4 equals 0. And it says estimation is to be one decimal place. How we do this is you want to treat this as your target. So this is our target function. Okay, but we are coming from a different cubic. So what you do is you compare where we're coming from with the target. We can see that this does not have a 2, for example, whereas our function now does have a 2. So what I want to do is I want to get rid of the 2 by dividing through by 2. And of course, this will affect every other term. X cubed, so 3 divided by 2 is 1.5. 4 divided by 2 is 2. 0 divided by 2 is 0. Okay. Our target has negative 3x, whereas we have minus 1.5x. So to get negative 3x, I'm going to take away 1.5x both sides. This becomes x cubed minus 3x plus 2 equals negative 1.5x. Notice now that our equation, our left side, is equal to the target. Now this is saying we need to equal this to negative 1.5x. This would mean that minus 1.5x is a value for an equation on the right hand side. So y equals negative 1.5x. So what I have to do now is I need to draw this on the left side diagram. One way that I can draw this is simply just plug in the value for x. For example, if I was to plug in the x being minus 2, so y equals minus 1.5 times minus 2, I'm going to get back 3. So I put 3 here, and this is going to the origin, and I'll just draw a line through that. Just doing a different colour. Oops, let's try that again. There we go. And then you just read off the graph from here, and that'll be that done. So this would be this point here, that's negative 1.6. So this would be negative 1.6. That's finished. Question number 6, we have an equation of a straight line. Part A, a line passes through 4, 6 and 12, 2. Okay, find the equation of the line. Okay, remember our equation of a straight line is in this form, y equals mx plus c, where we must find a gradient and a y-intercept. I'm just going to label these x, y and x, y. Remember, to find the gradient, we can do y2 minus y1, change in y over change in x, x2 minus x1. Make sure you're consistent with the direction you're going through. So I'm going to go from this side to this side. So I'm going to call this 1, 1, and this 2. So this would be 2, take away 6, divided by 12, take away 4. So that's going to be minus 4 over 8, which is minus half. So now that I have the gradient, I can plug in the gradient to y equals negative half x plus c. And in order to complete c, I need to substitute in y and x values. Now remember, it's going through two different points, 4, 6 and 12, 2, which means I can sub in either of these. I'm going to choose 4, 6. So y is 6, x is 4. Now let's see what happens. 6 equals negative 2 plus c, so c must be 8. Now that I have the two values that I need, I can just plug these in, and that'll be the final answer for A. Part B, write down the equation of a line that is parallel to the straight line. Now, so what makes it parallel? It must have the same gradient. Just a quick reminder, if I have a line that looks like this, a parallel line will have the same steepness, and even though this line is below the red line, it still has the same steepness, so same gradient. So part B, if it has the same gradient, I could just say minus half x. It really doesn't matter about the y-intercept. As long as it's not the same, I could say plus 6, for example. Part C, show that 3y equals 4x minus 14 and 4y equals minus 3x plus 48 are perpendicular. Okay, now when we're dealing with perpendicular lines, just a very quick example. If we have two lines that are perpendicular, that's going at right angles to each other. Now the rule is here is that if we have two gradients, m1 and m2, if we multiply them together, we get a product of minus 1. But in order to read the gradient correctly, I need to put it in the form of y equals mx plus c for both. So let's go from equation 1. Okay, so just put it down here. So 3y equals 4x minus 14. I want to divide by 3 just to get y on its own. So that'll be y equals 4 over 3x minus 14 over 3. Equation 2, we have 4y equals negative 3x plus 48. Divide 3 by 4. So y equals minus 3 over 4x plus 12. Just extract their gradients. And notice that if I did times these together, I get negative 1. So therefore, they are perpendicular. Okay, it's finished. And very quick indices questions. 7a, this is saying 4 to the power of negative 2. Remember, if we have x to the power of negative power, all we do here is we flip it upside down and attach the power back on, but that'll be positive. So this would be 1 over 4 squared, which would be 1 over 16. Part B, we have a fractional power here. Remember, with fraction powers, it will be a root. So we have x power of a over b. This would become the root of x. Now the denominator goes on the outside and the numerator goes on the inside. So this becomes the root of 16. 2 goes on the outside, the 3 goes on the inside. In these situations, I recommend doing the roots first. The square root of 16 is 4, but we still have this power of 3. 4 cubed is 64. That's finished. Question 8, slightly tougher indices questions. Part A. This is a raising powers question. So you times the powers from the outside to the inside because of the brackets. Treat the 8 with a power of 1. So this becomes 8 to the power of 2 over 3. Then e, so we've got 15 times 2 over 3. Remember, this is just a fraction. So 15 times 2 over 3, this would be 30 over 3, which is 10. So this becomes e to the power of 10. Now 8 to the power of 2 over 3, similar to the last question, we can just deal with this very quickly. That's going to be a cube root of 8 squared. I will do the cube root first. So that would be 2 to the power of 2, which is 4. So this becomes 4e to the power of 10. Part B. Now these sorts of questions cause a lot of problems, but you just need to remember how to manipulate bases, and it's much more simple than you think. For the right hand side, for example, 1 over 81, I'm just going to write that in a different form. 81 to the power of negative 1. Now notice that we have a 3 on the left hand side and 81 on the right hand side. Now 81 is a multiple of 3 by power as well. This will be, so 81 will be equal to 3 to the power of 4. Just double check that. So 3 times 3 times 3 times 3. That's 9 times 3 is 27 times 3 is 81. So this becomes 3 to the power of 2x equals 3 to the power of 4 to the power of negative 1. But when in this situation, if the bases are the same, that means the powers are the same, as long as there's nothing else left other than just the terms at the base. So 2x equals negative 4. Divide through by 2, so minus 4 divided by 2 is minus 2, and that is our final answer. Question number 9, we have an arithmetic sequence question here. The second term in the arithmetic sequence is 4, and the fifth term is minus 5. Work out the nth term of the sequence. Okay, so just to put it in context very quickly, if we have 2, 5, 8, and then 11, our common difference on the arithmetic sequence is plus 3. What you do with the plus 3 is you times this by n, where n is the position in the sequence. Then you get the first term, take away the common difference. So this would be minus 1. So this is our position 1, 2, 3, 4. So for example, position 4 is 11. So if I multiply 3 by 4, that'll be 11. So I know that this works. So going on to this question, we have 5 terms. 1, 2, 3, 4, 5. Position 1, 2, 3, 4, 5. The fifth term is minus 5, and the second term is 4. If I want to get from the first term, which is a, to 4, I know that I have to add common difference of d, and that would be the same between every single term. So if I want to get from 4 to minus 5, I would have to add 3d's, sorry, and that would equal minus 5. What I could do is I could solve here for d, so take away the 4, so 3d equals minus 9, so d is minus 3. You can get a negative common difference. Okay, so if I go backwards from d, so these are no longer d's, I know that I have to take away 3's to get from the left to the right. But if I'm going backwards, I would have to add the 3. So 4 add the 3 would be 7. So this is going down by 3's. 1, that's going to be minus 2. There's our sequence complete. But it's saying work out the nth term. Okay, so minus 3n, and then remember, the first term take away the common difference. But do be careful here. This is a negative 3 already, so it's 7 minus minus 3. So minus 3n plus 10. That's finished. Question number 10. Write an expression in terms of n for the quadratic sequence in the form of an squared plus bn plus c. Okay, now with a quadratic sequence, there is a second common difference, but not a first. So 1, our first difference, as you can see, from getting from 5 to 11, I have to plus 6. To get from 11 to 21, I have to plus 10. To get from 20 to 35, plus 14, and this would be plus 18. If I go again, there is a common difference of 4. Now if you use this 4, and you divide by 2. So 4 divided by 2 is 2, and this will be your coefficient of the n squared. So that's 2n squared. So this part of the equation is done. But what we want to do is we want our arithmetic sequence part. What you could do here is write down the original again. And then what I want to do is I want to put 2n squared here. This will be our original, and 2n squared below. Okay, so n again is the position in your sequence. So that's 1, 2, 3, 4, 5. So if I do n squared, 1 squared is 1 times by 2, this will be 2. 2 squared is 4, times by 2 is 8. Do the same for all of these. 3 squared 9 times 2 is 18. 16 times 2 is 32. 5 squared is 25 times 2 is 50. Then what we could do here is you take away, and this will give you your arithmetic sequence. But notice how it's just 3. If the sequence is just the same number, then it's just 3. So our final answer is 2n squared plus 3. Why not check a few just to see that this is right, because these are typically worth about 3 marks. You can easily check if you're right or not. So if I select position 3, 2 times 3 squared plus 3. So that's 2 times 9, 18 plus 3 is 21. That works, so I know that I've got it right. So this is our final answer. Okay, so this is a forming equations question based on its trapezium. So the fact that they're giving us the area must involve the area. So the area of the trapezium is a plus b divided by 2 times the vertical height. So I could call the a and the b x plus 5 and 3x minus 2 respectively, as I've already labelled. So I'm going to add the 2 together at the top. X plus 5 and 3x minus 2. You might not be able to see this very well, but those are the two expressions. And then we're going to divide this by 2, and then we're going to times this by the vertical height, which is 2x minus 3. So dealing with the numerator first, this is 4x plus 3 in brackets times by 2x minus 3. I could now divide this by 2, and this is equal to 133, which I also should have put up here. Okay, expanding and simplifying the numerator. Oh, I do that second actually. What I'll do is I'll times out the 2, so then we're going to get 4x plus 3, and then 2x minus 3 equals 266. Times out the brackets, so that's going to be 8x squared minus 12x plus 6x minus 9 equals 266. Simplify the left-hand side, 8x squared minus 6x. And then if I take away the 266, I will get minus 275 equals 0. And that's finished. Part B, find the value of x, show you're working clearly. This is an example of where if you don't know how to do part A, you can still do part B. So a lot of these multi-part questions, don't give up on a whole question just because you couldn't do the first part. This is a follow-on question, but we know what we have to solve and we know what the equation is. So the equation is 8x squared, take away 6x minus 275 equals 0. What I would do here is, as it's a calculated question, probably need to use the quadratic formula. Now, if we need to use a quadratic formula, that's fine. They do give it to you, but what it is x equals minus b plus minus square root of b squared minus 4ac divided by 2a. Okay, so a is 8, b is minus 6, and c is minus 275. We can base this off the quadratic format, ax squared plus bx plus c equals 0. So that's why these are what they are. What I can do next is put it into the quadratic formula. So this would be minus 6 plus minus b squared, which is 36, minus 4 times ac. So 4 times 8 times negative 275 all over 2a, which, so a was, sorry, I could get rid of that again. So that's 2 times 8, which is 16. So I can get rid of the 2. So this could be 16. Okay, so then what I can do is sort out this bit here before you put everything in a calculator, because just tidy that part up. It just makes it much more easier just to deal with when you put it into the calculator. So you could put that part that I've highlighted red separately into the calculator, and that will get you 8836. And it should always be a positive, by the way, inside the square root, because you cannot square root a negative, only a positive term. Now, you will get 2 solutions, because remember, we do have a plus and minus, so make sure you do the plus and minus. So the 2 solutions in this case, 2 decimal places, or 1 decimal place, is 6.25, or it would be negative 5.5. As this is a real world type problem, we can't just accept both the answers. It's either going to be 6.25 or negative 5.5. It cannot be negative 5.5, because well, if you think about it, if I put in negative 5.5 for this this here, which is 3 times negative 5.5 minus 2, I will get an answer that is negative. And you cannot have a negative length. So it cannot be negative 5.5, it must be 6.25. Question number 12. Prove algebraically that the difference between the squares of two consecutive integers is equal to the sum of the integers. Okay, so this is a question where you must use algebra. You cannot just use numbers because you will not get the full marks here, or any. The difference between the squares of two consecutive integers. So this is one integer after another. If we're talking about integers here, for example, if I say 2, the next one is obviously 3. If I was to label the 2 n, the 3 would therefore be n plus 1. Now it wants a difference between the squares of these two. That's what I can do for any consecutive integer. If it's a difference, I probably want to get the biggest one, which is n plus 1 squared, take away the smallest one. And then just use double brackets for n plus 1, take away n squared. That's going to be n squared plus 2n plus 1, take away n squared. These will cancel, and then we will get 2n plus 1. And actually, this is an expression for an even number. Okay, but it's saying here that the difference between the squares of two consecutive integers is equal to the sum of the integers. Okay, so it doesn't matter if this is an even expression. The question is not asking that. It's telling us it's equal to the sum of the integers. The sum of the integers that'll just be n plus 1, which is 2n plus 1. And we can see that this is equal to 2n plus 1. So the left side is equal to the right side, which completes the question. Question number 13, we have an identities question. Work out the values of a and b. So identities is where the left side is directly identical to the right side. And what we do here is we compare like for like. What I'm going to do first is I'm going to start by expanding the brackets. So we have 3x squared minus 15x minus 1 plus 5 plus 8x plus b, which is identical to the right hand side, which is 3x squared plus 11x minus 1. So on the left hand side we have 3x squared minus 15x. I'm going to move the ax right next to the x term, so that's going to be plus ax minus 1 plus b is 4, but I do also have a b there, so I'm going to put plus 4 plus b. Next, what I want to do is just compare like for like, really. Now, I'm going to highlight the x squared terms. We only have this as the x squared term. Okay. In terms of the x terms, we have this. And then in terms of the integer, or the number, the constants, we have minus 1. What I'm going to do next is sort out the x terms. So minus 15x plus ax is equal to 11x. If I just factorize out the x, so that'd be minus 15 plus a brackets x equals 11x. You can see here that minus 15 plus a has to be equal to 11. A must then therefore equal 26, because I just moved the minus 15 by adding. Okay, that's the a term sorted. In terms of the 4 plus b, as this is equal to minus 1, b is clearly minus 5. And that will be the final answer to that one. Question 14, we have two simultaneous equations. One is the easier one and b is the harder one. Okay, let's just go for a first. 4x plus 2y equals 10. And 5x plus 3y equals 12. I'm going to use the process of elimination here because I think that's the easiest way to do. So remember, the process of elimination is matching up the coefficients of either the x or the y. I'm going to match up the y, and I'm going to do that by using a common multiple, which is 6. So I'll times the top by 3, times the bottom by 2. This will make it 12x plus 6y equals 30. And the bottom will be 5x, sorry, so I need to multiply by 2. 10x plus 6y equals 24. And as you can see, the coefficients of the y's have matched up. Now, how do I get 0? The signs are the same. Be very, very, very careful at this point because a lot of people get this part wrong. I would say that this is the most common part where people do get it wrong. This is fairly obvious because we're just going to take away to get 0, but if you do have a sign change, do make sure you get 0, whatever you put here. Okay, so this will become 2x, this will become 0 of course, and this will 30 take away 24 is 6. So x is equal to 3. If x is equal to 3, I can just plug it into either equation 1 or 2. I'm going to go for 1, so 4 times 3 plus 2y equals 10. That's 12 plus 2y equals 10. Take away the 12, so 2y equals minus 2, divide by 2, y is minus 1. So x is equal to 3 and y is equal to minus 1. Part B, so this is one of the harder questions, usually right at the end, or towards the end actually, of an exam paper. They're usually worth 5 marks, that's why I put 5 marks here. And it will involve quadratics, so you must be good at quadratics to tackle these sorts of questions. The common or general rule here is get the line equation, which I'll call equation 2, rearrange for x and y, which it already has been, is rearranged for y, and then we're going to sub this into y. We have an expression for y, and I'm going to take the y out in equation 1 and sub in x plus 7. So this will be x plus 7 squared, put in brackets again, plus x squared equals 29. Double brackets for the x plus 7, plus x squared equals 29. Expand and simplify the brackets, so this will be x squared plus 14x plus 49 plus x squared equals 29. Join the x squares together, so that's 2x squared plus 14x. I'm going to take away the 29 to the left hand side because remember quadratics should be equal to 0 when you're factorising. So this will become plus positive 20 equals 0. As we are solving, I can actually reduce this by a factor of 2. This will make it much easier to deal with. So that'll be x squared plus 7x plus 10 equals 0. Now factorise is quadratic. So remember again, we're going to do multiplication of 10 and addition to get 7. So two numbers that multiply to get 10 and add to get 7. And in this case, it's going to be 2 and 5. All positive equals 0. Okay, so what we have here is that one of these, either x plus 2 or x plus 5, must be 0 in order to get 0 here, as these are multiples. So either x plus 2 could be 0, so in which case this would be negative 2, because negative 2 at 2 is 0, or this would be negative 5. Negative 5 plus 5 is 0. So either of these could be the solution. Okay, so next what we do is we're going to work out the value of y, which is equation 2. So x plus 7 equals y, and I'm going to use minus 2 first, so minus 2 plus 7 equals 5, minus 5 plus 7 equals 2, and there we have our solutions. X is minus 2, y equals 5, or x equals minus 5, and y equals 2. Just for a little bit more context with this question B, the top equation, x squared plus y squared equals 29, is actually a circle equation where the center is 0, 0. So let's just quickly draw a circle, and let's say the center is 0, 0 there. What it's saying is that this bottom line, y equals x plus 7, intersects this graph, this circle, at 2 points, which we see here, minus 2 and 5, and minus 5y is 2. So let's say minus 5, and then y is equal to 2. So let's say that's there. And then we have minus 2 and y is 5. Let's say that's there. So essentially what this graph is doing is it's hitting these 2 points. So the line would be like that, and it's intersecting these 2 points. So I just thought I'd give a little bit more context with what's going on with B. Question 15. This overall topic is iteration, but it's very common to see a part, or part A in this case, that we must rearrange for one of the terms. So we need to rearrange this cubic equation into x equals cube root of 7 minus 2x. So I'm just going to start by writing the cubic equation. Okay, this is equal to 0. And what I'm going to do is figure out which term has been rearranged. The fact that we have a cube root means this has been rearranged for x cubed. So I'm going to take away the 2x and I'm going to add the 7. So 7 take away 2x. Now cube root both sides. So we get 7 minus 2x. And those are all the steps I need to complete the question. Part B. Now, as you can see, this iteration formula has been arranged from the previous question. So again, if you can't do A, you can certainly do B. Remember, iteration is about homing in unto the solution. And it's saying we must use this iteration formula 3 times, starting with x0 is 2. So I'm just going to start off by saying, well, if I start off with x0, the next iteration will be 1. So this will be a cube root of 7 take away 2 times xn. In this case, n would be 0. So that would be 2. Okay. Now, if I do that, what I'm going to get for the first answer is 1.4422. And what I would recommend actually is just write out the whole number, or just write out all the digits. So 957, that's 1. And then what you do in your calculator, you don't need to put this decimal back in, because remember, in iteration, you put your previous answer back in. Okay, so if I just set it out like this, so 7 minus 2. Now this next part, this xn, will be x2. So sorry, x1. Sorry, to be x1. So this will be x1 in here. All right. So it's our previous answer. So we would put this into there. Okay, but you don't have to do that. If you just go back into your calculator, you can just press the answer button and it will immediately recognize it's your previous answer. And if we do that, we get 1.602 5 or so yeah, 335, and then that's 155. Okay, so for the third iteration, if you press equals again, it will automatically find the next iteration. So this is 1.5597. And now to 2 decimal places, it's 1.56 to 2 dp, and then that's done. Question number 16. The diagram shows a rectangle. Okay. The area of the rectangle is a centimeter squared. Given that the area has to be less than 3x plus 27, find the range of possible values of x. Okay, this is a quadratic inequalities question. And a lot of people will get the inequality signs wrong. So I'll very quickly show you how you can get it right every single time. First of all, what I want to do is just set out an equation for this. This is going to be 2x minus 4 times 3x plus 2, length times width, because it is a rectangle. And what this is saying is this is equal to the area, but it's also less than 3x plus 27. Okay, so I just want to expand the left-hand side. That's going to be 6x squared plus 4x minus 12x minus 8 is less than 3x plus 27. Okay, that's 6x squared, and that's going to be minus 8x minus 8. I'm going to move, well no, I'll just leave it like this for now. The next line, I'm going to move the 3x and the 27 to the left-hand side. So this will become 6x squared minus 11x, then minus 8 minus 27 is minus 35, is less than 0. Okay, now I've already gone through the quadratic formula, but you will use the quadratic formula for this one. So again, I'm just going to write it out on here. X equals minus b plus minus b squared minus 4ac over 2a. If you use this quadratic formula, again, I'm just going to skip ahead and just tell you the solutions. You will get 7 over 2, and you will get minus 5 over 3. Okay. Now, you have answered part of the question, but it is still crucial to get the inequality right, because it's saying find the range, which tells us it's a inequality. Okay, or an interval. So what we need to do here is work out what it can be. Now, remember, for a quadratic, y is equal to ax squared plus bx plus c. If I put a value of x in, I get a value of y back. So essentially, this equation is equal to y, which means that this equation is equal to y. So if I just replace this for y, for example, this would then say that y is less than 0. What I can do then is, using these solutions, I'm going to plot these 2 points. So let's say minus 5 over 3 is here, and 7 over 2 is somewhere over here. As this is a positive quadratic, it will go through like this. Now this is saying, where is y less than 0? Well, we know that above the x-axis is positive and below is negative. So essentially, we're looking at the quadratic below the x-axis, which is this part. Okay, now what will happen is it will actually be this part of the curve that I want. If it was above, it would be this part of the curve and this part of the curve. But I'm only focusing on the bottom one because that's what I want. Now, as you can see, it's between these 2 points. That's because that's where the curve correlates with that. So therefore, the answer is x is less than or more than minus 5 over 3 and 7 over 2. If you're not sure on the inequality sign, it's going to be the same as that. So if it has a line underneath, yes, there would be a line underneath. But there isn't, so that would be the answer. Number 17, we have a completing a square. Express x squared plus 8x plus 5 in a form of x plus m squared plus n. So when you do see this, you might immediately think, okay, that's completing a square. And it's pretty straightforward, this question is, if you know how to complete a square. It's a quick reminder, when we're completing a square, could put brackets squared in, put an x there. Whatever this term is, the x term, you divide that by 2. So 8 divided by 2 is 4. Now, if I was to square these brackets, which would be double brackets, just put it in the corner here. Eventually what would happen, I would times the 4 by the 4, which will give me 16. But the problem is, there is no 16. There is a positive 5. So you remove what you don't want and you add what you do want. So this would then become x plus 4 squared minus 11. And that's actually finished. So m is equal to 4 and n is equal to negative 11. Now, one of the good things about completing the square, it does help us work out the turning points. And the turning point is based on this part and this part. Whatever's inside the brackets, you invert the sign, so it'll be negative 4. And whatever you have on the outside is leave alone. So essentially what this is saying is that this quadratic will have a turning point of minus 4, minus 11. Okay, so essentially what it's saying is that if we have an axis here, minus 4, minus 11, and this is a positive quadratic, it will go through something like this, okay, where the intersection is 5, and as you can see, the turning point which we've worked out is minus 4, minus 11. Question number 18. The graph of y equals 2x plus 1 is drawn on a unit grid. The region R satisfies all these inequalities. Show that the area of region R is 12 units squared. Okay, so we need to look for that region first. Y equals 2x plus 1 is already drawn, so this one's already done. Y is more than or equal to 5. Now be very careful. That sign is saying more than or equal to. If it has a line underneath the inequality sign, we use a straight line. So if you get either of these, it's a solid straight line. If you don't have a line underneath, do remember it's a dashed line, and you will get marked down if you don't use the correct line. So do be careful there. So y is more than or equal to 5, so I'm just going to locate y is equal to 5, and just draw just a line there. So this is y is equal to 5. With the x plus y is less than or equal to 13, I'm going to rearrange for y equals mx plus c. So I'm going to take away the x. So that's what we have. Okay, so our y-intercept is 13. So we're going to go from there. And what I can do is, if I link it to the x-axis, that's where y is 0. So 0 equals minus x plus 13. Move the 13 over, so minus 13 equals minus x. So therefore positive x must be equal to 13. So it would go there. And again, this is a straight line. So I'm going to draw this solid line all the way there. And that is everything. So this is going to be x plus y equals 13. Okay, so now to find region R. Now, I'll just go to the easy one first, where y is equal to 5 or greater than 5. So what this is saying, the value of y is greater than 5. So we are looking for this side up, because where is the value of y greater than this line? It's this side up. Okay, the next one, y is less than 2x plus 1. So where is the value of y less than this line, which has already been drawn for us? It'll be this side of the line, because that's where the values of y is going to be less than this line. On the other side, it'll be greater than. So that's one's done, and this one's done. And then lastly, this is saying, where is y less than minus x plus 13? Well, it's going to be this side. Now, which region do all the arrows converge on? It's this part here. So this is region R. Okay, so I'm just going to call that region R. And now it's saying, show that this area is 12 units squared. Well, this is just a triangle. So half base times height. So the base is 1, 2, 3, 4, 5, 6. So I'll just write 6 there. And the height is 1, 2, 3, 4. So this is, let's go from there to there is 4. Half base times height, or 6 times 4 divided by 2 is 12 units squared. And that's done. Number 19, part A. If fx is equal to x squared plus 2x minus 15, then find the new x-intercepts if y is equal to fx minus 3. This is a graph functions question, and we need to first identify what type of transformation has taken place. So for part A, what's happening here is we have an f, then x plus c. This is a x shift. Now, you might think this is moving 3 units to the left, but it's actually not. It's the inverse. So this is telling us it's moving 3 units to the right. Or in vector form, you could write this as 3 units to the right, no movement vertically. So we need to work out the x-intercepts. So essentially what this is saying is that we have a quadratic, and these are our intercepts. Now our intercepts is when y is equal to 0. So x squared plus 2x minus 15 is equal to 0. Then we just need to factorize. And this will be 3 and 5. Positive 5, negative 3. So x is equal to 3 and x is equal to negative 5. So our x-intercepts are minus 5, 0 and 3, 0. Okay, so this part will be negative 5, 0, and this part will be 3, 0. Our new intercepts are now shifting 3 units to the right. So if I transform this using 3, 0, this would be negative 2, 0, and 6, 0. And that would be our final answer for part A. Part B. Find a new equation for y equals fx plus 2 minus 3. Leave your answer in the form ax squared plus bx plus c. So this is a mix between graph functions and functions. Okay, so essentially what we're plugging in is x plus 2. Now, just like part A, this is an x shift. This part here is an x shift. This minus 3 on the outside is a y shift. So again, just to quickly go through that, we have fx plus c, which is the x plus 2 part. This is the x shift. And then if we have the fx plus a, so this is the y shift. So just to highlight this, x plus c is this part, and then the plus a is the minus 3 part. So it's moving 2 to the left this time because it's plus 2. Remember, you do the inverse. Then it's moving down by 3. But really what we need to do is we want to find out the new equation. So if f of x is equal to x squared plus 2x minus 15, what I want to do is, as you can see, I want to plug in x plus 2 into here. Okay, just a very quick bit of context here. For example, if I plug in a, this will swap out all of the x terms for a, so that'll be a squared plus 2a minus 15. It's just that here I'm plugging in an expression of x plus 2. Okay, but I can't forget the minus 3 as well. So this will become x plus 2 squared plus 2 times x plus 2 minus 15, then minus 3. Okay, so quite a lot of expanding and substitution here, but that's fine. We can sort through this. Okay, so then I want to just expand this, so that's going to be x plus 2 plus 2x plus 4 minus, that's going to be minus 18. So this would be x squared plus 4x plus 4 plus 2x plus 4 minus 18. And this will become x squared plus 6x, that's 8 minus 18. That's going to be so that's minus 18, so 4. So that would be minus 10. Question number 20, we have a functions question here. For all values of x, we have f of x equals x plus 1 squared and g of x equals 2 brackets x minus 1 brackets. Show that gf of x is equal to 2x then x plus 2. Okay, so this is the composite functions where the second function will go to g. So f is x plus 1 squared, and this will go into this x there. So I'm going to open up g, and I'm going to put in, or state that I'm putting in x plus 1 squared. Okay, so that'll be 2, and then we use square brackets here. So instead of x, I'm going to use x plus 1 squared and minus 1. Then what I want to do is expand the brackets of x plus 1. So this would be x squared plus 2x plus 2, oh, forgot the minus 1, minus 1. Just tidy that up. That's going to be x squared plus 2x. Oh, sorry, made a mistake there. That should be 1, because 1 times 1 is 1. So this will be 0. Okay. What I could do here is times out the 2. So that would be 2x squared plus 4x. And this is 2 terms here, so I can factorize with single brackets. So take out the 2, and I could take out x. So in the inside, I will need an x plus 2. And as you can see, that is what they're asking. Part B, find the inverse of g with an input in 7. Okay, so gx is equal to 2x minus 2. So I've just multiplied out the brackets. Now, when you're doing the inverse, what you can do is just take out the notation of the function, which is g of x, and just replace it with y, because it's essentially the same thing. So y equals 2x minus 2. And then what you want to do is rearrange for x. So y plus 2 divided by 2 is equal to 2x. Next, what you can do is swap around, y and x. So this would be x plus 2 over 2. And as if you notice now, this is actually the inverse of the original equation, 2x minus 2. So I've achieved the inverse, so g minus 1x. Now that I've done that, what I can do is I can input 7 into the equation. So I'm going to open up g of x, or the inverse of g of x, sorry, and I'm going to put in 7. So this is inputting 7 in replace for x. So that'll be 7 plus 2 over 2, so that'll be 9 over 2, and that will be finished. Okay, last question, and it has been a long section. 21. Find the equation of the tangent at 2, 6, which hits a circle with the equation x squared plus y squared equals 40. Leave your answer in this form where a, b, and c are integers to be found. Okay, so this is a circle equation, center 0, 0. Right, so what I can do is I'm just going to draw a circle, and I know that it has a center 0, 0. I would just sketch these out if you can, because having some visual data is quite useful. Because it's saying here the tangent, remember tangent touches a curve but doesn't go through it. And it's at 2, 6. So let's say 2, 6 is here. That means our line, our tangent, will go through at that point. So let's just draw a tangent. So let's say something like that. And what it's saying is, at this point, this is 2, 6. Okay, so we want to work out the equation of this tangent. So how do we do that? If this is the center, where does center meet the circumference, or the radius in this case, the radius meets a tangent at 90 degrees. Okay, so that means I can work out the gradient of this dashed line, because let's say that's the radius there. Okay, the height, because it's coming from origin, must be 6. Okay, so change in y is 6, and the change in x is 2. So that's going to be 6 over 2, which is 3. So the gradient of this dashed line is 3. Now what I can do next is, if the gradient is 3, remember the rule of perpendicular equations, or perpendicular straight line equations. If we multiply the equations, we get -1. So if one is 3, the other one must be -1 over 3. In this case, that's the tangent, the red solid line. Let's go into the tangent. I'm just going to call this L1. So L1, the gradient, is equal to -1/3. Therefore, y equals mx plus c. This would be y equals -1/3 x plus c. And we know that it goes through 2, 6. Nearly there. So y would be 6, the x value would be 2, plus c. So 6 equals -2 over 3 plus c. Now I want to work out c, so what I'm going to do is I'm just going to times out the 3. So that's going to be 18 equals -2. Don't forget to times 3 by the c if you are doing it this way. So that's going to be 3c. Add the 2, so that's 20. So 20 equals 3c. Divide by the 3. So 20 over 3 equals c. Very close now. So y is equal to -1/3 x plus 20 over 3. But we're not finished yet, because it says ax plus by plus c, so 1's in that form. Plus it says these are integers, but we have fractions here, so I'm going to times out the 3. So both terms are being divided by 3. So if I times out the 3, that will remove the 3 for both terms on the right. So this 3y equals -x plus 20. And we want everything on the left-hand side. So this will be 1x plus 3y minus 20 equals 0. So essentially a is equal to 1, b is equal to 3, and c equals to -20. Okay, so this was a very long section. I hope this was helpful. Some of these questions were quite tricky. I would say quite a lot of these were level 7, but I hope that was helpful, and I'll see you in the next section.